Okay, so to explain to you a little bit more about what a cross section is, I'm going to try something. It's kind of silly. I'm going to go to a video. We'll play a video in my video. Let's see how this. It's only a minute long, and it's cute. It's going to pause.
Slicing solid, three-dimensional figures results in different two-dimensional shapes depending on how you slice them.
If you cut through a cylinder with a geometric plane parallel to the cylinder's base, the two-dimensional cross-section is a circle. Any way you slice it, you can get two-dimensional shapes from three-dimensional figures. When you slice a cylinder from top to bottom that is perpendicular to its base, then look at the cross-section straight on. You get a rectangle. What happens when you slice a square pyramid? If you slice across the pyramid with your plane parallel to the pyramid's base, the cross-section is a square. If you slice with your plane perpendicular to the pyramid's base, the cross-section is a triangle. Remember, you're slicing a solid, three-dimensional figure with a geometric plane. You can slice in any direction. Just keep in mind that shapes can look different when you look at them from different angles. So orient the cross-section on the geometric plane. Slicing diagonally can produce different shapes, such as an ellipse or a trapezoid. Understanding the two-dimensional shapes that result from slicing solid, three-dimensional figures is important for geometry and ninjas.
Okay, so like I said, that was pretty short, but it gave you a good idea, and I will put a link to that so you can go back and watch it again. I will put a link to that on the webpage, or I'll have Mr. Minion do it. So this one says, describe the two-dimensional shape of a cross-section that is parallel to base of a prism. Well, here's a couple of prisms right here, and they're showing you right here, if we take that plane and we slice it, we be sure that it's parallel to that base, then what shape will we get? And I believe that's going to be a rectangle when we take it apart and look at it. Parallel to the base often gives you the same shape as the base. But this one, I see. This one we got to be careful. So this rectangle down here is not the base of that prism. The base of that prism is actually the triangle. If we slice it, we would have to slice it here and go down. So we would be slicing it, this way. And we would be slicing it this way. So, anytime you slice it parallel to its base, it should be its base, especially with the prism. Describe the two-dimensional shape of a cross-section that is parallel to the base. It's the same shape as the base. Describe the two-dimensional shape of a cross-section that is perpendicular to the base of the prism. So, perpendicular, that's a little bit harder to see, but when we cut it perpendicular, okay, so this one's perpendicular to the base because the base right here is the triangle. The triangle is the base. So this cross-section right here is perpendicular to the base. And so when we cut that open and we take a look at that shape right there, it's going to be a rectangle. This one's going to be a rectangle. And then it says below down here, these are the result. These are the cross sections of a hexagonal right. Okay, and it says label each cross section as either being parallel or perpendicular to the base of the pyramid. So again, these are really, really hard for me to see. First of all, I would need a hexagonal right pyramid over here. And I would draw it the best I could, but I'm actually going to go to, I believe, I got this one right here. So here is a hexagonal right pyramid, and they are going to do a few slices for us. So the first one they're going to do is parallel to the base. So if we slice this anywhere along parallel to the base, then you see that we're just going to get a shape similar to what the base is. It's going to be a hexagon. So if we go back now and look, we know that this one right here is parallel. This is parallel to the base, and this one is parallel to the base. Why is this one smaller? It's just farther up. It's closer. This one's closer to the vertex because it's smaller, and this one's closer to the base. All right, and then let's go back and let's turn that one off. Now both of these say perpendicular to the base, but they're going to do it in two different places. So let's see, this one's right down the middle. If you include the vertex and you go perpendicular down, you see that we get a big old triangle. So let's go back over here and see. So this one is perpendicular to the base. I'm perpendicular to the base, but I went through the vertex, and that's important to see that you're going to get something a little bit different. And these two right here look like they're both trapezoids. So let's go back over here and see that if we go perpendicular to the base but not through the vertex, there we go, we get that trapezoid. Okay, so what's the difference between the two trapezoids? One's smaller than the other one. So it looks like the higher, the closer you are to the vertex, maybe the bigger your trapezoid's going to be. The lower this point gets right here. Oh, look, I can lower it. The lower this point gets, the shorter the thing's going to be. So as I get closer, bigger, and as I get lower, smaller. So that's pretty cool. So we can see that our two right here, this is perpendicular. This is closer to the vertex. And this one's perpendicular and it's closer to the base. If you guys are not one that can visualize this, then I strongly suggest that you just do a whole bunch of searches, Google it, because that's exactly what I just did, how I found it. I'm not good at visualizing these cross sections. If I have the shape that I can sometimes a little bit get close, but if I don't have the picture at all, it's almost impossible for me to visualize. So yeah, you might need to, get some examples. It says sketch several cross sections that are parallel to the base of a square pyramid and sketch them that are perpendicular. So basically, they want something similar to what we just did on the other one. They want you to give them some sketches like this. So we're going to need to start with a square pyramid. Okay, so this time we're going to have a square pyramid. I'll try my best to draw it. It doesn't look very square, but okay, so there's the square pyramid, and it's going to be sketch several cross sections. Okay, well, we know that if it's parallel to the base, then we're just going to get squares parallel to the base. We're going to get a smaller square. What's the difference between these two? This one's closer to the base. This one's closer to, if we you know, cut it off right there, we're going to get that square. Now, if they're perpendicular to the base, you've got three things. It can be through the vertex, and if it goes through the vertex, I believe we're going to get a triangle again, okay? And if we don't go through the vertex, then we're going to be slicing it off like here, and it's going to come down like this, and come down like this, and come down like this. So I believe we're going to get perpendicular to the base, but not through the vertex. We're going to get a trapezoid. Okay. And what happens if we cut the corner off, I wonder? If we go perpendicular to the base, but we cut the corner off, I think right then we would get a triangle. Okay, perpendicular to the base, but not parallel to the base edge. Right? So the trapezoid is what we get when we go perpendicular to the base, but parallel to the base edge. Well, what if we, you know, cut that corner off? Then I believe we get a triangle. Okay, so that's, again, just going to take some practice visualizing. It's for the next video, you will need to have these problems worked. These problems and the practice, and I will go over the answers to these with you in the next video.